Now let me introduce the notebook of abalone dataset. The abalone dataset is retrieved from the USI machine learning repository using the fetch function. The physical measurements are stored as features x, while the number of rings representing age is used as a regression target y, like this. And the shape of feature matrix is checking using by this code. And also the notebook also checks the missing values. It is examined using by this code and shows no significant missing data is found. So there's no need to input the there's no need to input the arrow, and the dataset can be directly used for modeling. And also we also check the duplicates and the unique values and the information of the data frame. This is all preparation for the machine learning, and is exploratory data visualization is performed using by AutoVis library, which automatically generates distribution plots, correlation heat maps, and future target relationship charts. This visualization help identify patterns, skewness, and important predictors of abalone age. And the notebook also checks the skewness. These skewness of quantitative variable is examined to evaluate distribution symmetry. And many biological measurements features show positive skewness, which may reduce the effectiveness of linear regression, but can be handled well by tree-based models. And the categorical variable sex is converted into numerical form using label encoder so that machine learning can process the feature. And also the skewness of the target variable is approximately 1.11, indicating a clear right-skewed age distribution. This uneven distribution suggests the square error metrics such as MSE may be very sensitive to a small number of old abalones, and it provides motivation for considering non-linear tree-based models and that are more robust to skew data. And outliers in the target variables are identified using a Turkey-based rule and removed before modeling. The presence of many high-age outliers is consistent with the previously observed positive skewness, and removing this extreme value help prevent square error metrics from being dominated by a small number of observations. And we can get the box plot of target variables by this coding. It shows the most abalone age cluster around the median, while longer right whiskers confirms the previous observed positive skewness. And we can see from this code the dataset is separated in a feature matrix X and a target variable Y, where X contains full name numeric predictors after label encoding, and the Y represents the number of rings used for age prediction. And for the future importance, we can see the dataset is divided. The dataset is divided into training and testing, data subsets using 82 for the 220 holdout split, resulting in 3,341 training samples and 836 testing samples. This separation ensures the model performance is evaluated on unseen data, helping to detect overfitting and provide a realistic estimate of generation ability. And feature scaling is performed using standardization so that all predictors have zero mean and unique variance. The scaler is fitted only on the training data, so then applied to the test data to prevent data leakage. This step is essential for distance-based and gradient-based models such as SVR and neural networks. Well, a tree-based model like random forest are scale invariant. Feature importance derived from the random forest model shows the shell weight is by far the most influential predictors of abalone age, followed by other weight-related measurements such as Charcot's hole and Viscera weight. In contrast, sex and simple dimensional features contribute relatively little. And I think this pattern is biologically meaningful. And so here comes the most important step. And this step, the notebook trained and compared 8 different regression models using the same training and testing data to ensure a fair comparison. Each model was fitted on the standardized training set then used to predict the test data. And the notebook assessed the performance used MSE, MAE, and R-square, and also virtualized predictions versus actual values to check how closely each model follows the ideal diagonal pattern. This results shows multiple linear regression, and the ridge regression performs best with an MSE of about 5.1 and MAE around 1.61 and R-square close to 0.53, indicating a large linear relationship in the data. They also show a clear and fitting with R-square dropping to around 0.14, where a single decision tree had high variance and weak generalization with R-square around 0.21 near to, and non-linear models like KN and the neural network achieved R-square values near to 0.5 to 0.51. And also, we can from the notebook, we can find some clear and useful insights. First, abalone age is mainly related to shell weight and other growth measurements, which means biological age mostly depend on long-term growth rather than sex or simple size. And also, linear and ridge regression gives the best performance, which means in the real world terms, we can estimate abalone age using easy physical measurements and simple models, which can help fishers to have better management, and it's better for the ecological monitoring and sustainable harvesting. Thank you.